Hello, hi everyone, and the topic for today's lecture is direct retainers, indirect retainers, and tooth replacement in cast partial dentures. Now, these are the learning outcomes from the lecture, so please make note of that. Placed on the abutment tooth for the purpose of holding a removable partial denture. Here, in removable partial denture, abutment tooth is a tooth on which the clasp assembly is placed. Okay, the tooth which is just adjacent to the edentulous area. So, this is a clasp assembly, and these are the various components of a clasp assembly, which is basically a direct retainer. So first is the retentive terminal. You can say this pointy tip, this is the retentive terminal, and then we have this is whole part is known as the retentive clasp arm. Then we have the reciprocal clasp arm, we have the occlusal rest, we have the shoulder. This shaded area is called as the shoulder, and this is the body. And the seventh is the minor connector, which attaches the direct retainer assembly or the clasp assembly to the uh, cast partial framework. So next, coming to the requirements of a clasp assembly. All clasp assembly must be designed keeping in mind the retention, stability, support, reciprocation, encirclement, and passivity. Coming first to retention. Retention, the quality of the clasp to resist the forces acting to dislodge the components away from the supporting tissue, that is in a vertical direction against the gravity, is known as retention. And how do we ensure that the RPD has a retention? That is, we engage the clasp in the undercuts. The rest should provide vertical support to maintain the clasp terminal in its appropriate place, because if the rest is slipping, then the retentive terminal of the clasp assembly will not be in the proper position, and this will result in the dislodgement of the cast partial denture. The components must provide sufficient encirclement to prevent the movement of the abutment tooth away from the associated clasp assembly. Next, coming to the support. Support, the quality of the clasp assembly that resists the displacement of the processes in an apical direction, that is towards the supporting tissues or towards the denture based tissues, is known as support. And this primarily the support is provided by the rest and the rest seat on the abutment tooth. Next is the stability. The stability is the quality of the clasp assembly to resist displacement of the process in a horizontal direction, that is in the horizontal plane, and this is achieved by all the framework components, that is the major connectors, the minor connectors, the saddle, the denture base, they and the reciprocal arm, the retentive arm, they should all be sufficiently rigid. The second thing is the framework should be should contact the vertically oriented hard and the soft tissues, that is the lateral walls of the residual ridges and the lateral walls of or the axial walls of the tooth. They all provide or offer stability of the CPD frame. Next is the reciprocation. Reciprocation is the quality of the clasp assembly that counters the lateral displacement of the abutment tooth when the retentive clasp terminal passes over the height of contour. So as we know, the clasp assembly has a retentive arm and a reciprocal arm. So when the retentive arm passes over the maximum convexity of the tooth and engages the undercut, that is when the tooth lateral forces are applied on the tooth. To counter this, the reciprocal arm, which is placed on the opposite side of the tooth, that is on the lingual side of the tooth, will counter this lateral movement exerted by the retentive arm or the clasp. So the reciprocation is achieved by the rigid component that resists the lateral movement, which is known as the reciprocal element or the reciprocal arm. This may be cast clasp, or they may be the lingual plate in case of a mandibular major connector, such as Kennedy's bar or the double lingual bar or the lingual plate. They also act as a reciprocal arm in case of a CPD framework. Now coming to encirclement. So here we have the clasp assembly, this is the rest, this is the direct retainer, this is the reciprocal arm in blue. You can note the direct retainer is placed below the maximum convexity or height of contour of the tooth, whereas the reciprocal arm is placed at the height of contour of the tooth on the lingual side. So the reciprocal arm counteracts the lateral forces exerted by the retentive arm or the retentive terminal on the tooth, and this is known as reciprocation. Next is encirclement. Encirclement is how much of the clasp assembly encircles the tooth from the tip of the reciprocal arm to the tip of the retentive terminal. The greater the encirclement, the greater the support. That is, any clasp assembly should offer more than 180 degree of encirclement around the abutment tooth. So in this case, we can see we have a encirclement of at least 270 degrees. So this is a good form of encirclement for a direct retainer. Next is the passivity. Passivity is the quality of the clasp assembly that prevents the transmission of adverse forces to the abutment teeth when the process is completely seated. That is, when the process is seated, the retentive terminal should not engage the tooth or should not engage the undercut and exert lateral forces or tipping forces on the abutment teeth. It should be completely passive. Only when patient chews sticky foods or moves his tongue or performs any function movement when the clasp or the CPD framework is beginning to dislodge, that is when the clasp should become active. So other than that, it should be completely passive. The retentive arm should only be activated when the dislodging forces are applied to the RPT. Now coming to direct retainers, that is the clasp assembly. They are broadly categorized into two categories, that is intracoronal, that is within the contour of the tooth, and extracoronal, that is which are placed outside the external contour of the tooth. Now, internal coordinate attachments are basically precision attachments and semi-precision attachments. They are either manufactured uh, or custom made in the laboratory, or they are prefabricated, which are sold by different brands such as Rhine 83, which is a famous brand that produces precision attachments, and these can be incorporated in the contour of the abutment tooth by placing crowns, and then the one part of the precision attachment is then attached to the abutment teeth. Extracorneal attachments are regular conventional direct retainer or the clasp assemblies, which we have spoken about now, and depending upon how the retentive arm or the retentive terminal approaches the undercut of the abutment teeth, they are further categorized into two parts: the supra-bulge part, supra-bulge type of direct retainers, and infra-bulge type of direct retainers. So let's see what. So intracorneal attachments or intracorneal direct retainers, as I said, are basically precision attachments or semi-precision attachments that are incorporated within the contour of a tooth. So here we can see this is a crown, and this has one portion of it which is known as the male portion, which is attached to the crown, and the female portion, the other portion, is incorporated into the cast partial framework. So you can see over here, this is a crown with one portion of the precision attachment attached to it. It is also known as tenon or mortise. The male part is known as tenon and the female part is known as mortise. Or it may just be called as a male and female part. So these are very precisely fitting parts which are manufactured by machining the titanium alloy or nickel chromium or cobalt chromium alloys. And they have a very precise fit and offer excellent stability and good retention. Now, they consist of, like I told, two portions. First portion, metal receptacle. Second portion, which is attached to the removed partial denture, a male, a female, or tenon or mortise portion. And next, coming to the extracorneal retainers. Okay, extracorneal retainers are retainers which are placed outside the body of the tooth, and they are classified as supra-bulge or infra-bulge clasp. So basically, these are our conventional clasp assemblies which are cast from a wax pattern. So this picture here is wrong. This picture is a picture for a intracorneal retainer, that is sorry, this is a picture for a attachment. So there are two types. One is the clasp assembly, second is the attachments which are placed outside, which are attached to the crown, but they are not within the contours of the crown, but they are placed outside the crown. And this is the female portion, and the male portion is attached to the denture base of the cast partial denture, which goes and seats in this receptacle. So these are known as attachments, and since they are not within the confines of the abutment teeth, but they are outside the abutment teeth, way away outside the abutment teeth, they are called as extracorneal direct retainers. So this is the difference between a suprabulge and infrabulge clasp. A suprabulge clasp approaches the undercut from a superior direction, that is above the height of contour of the tooth, and then engages the undercut below the height of contour or height of convexity of the abutment tooth. Whereas an infrabulge retainer, such as this shown over here, which is a an I bar or Y bar, which are different shapes of a roach clasp. This is basically called as a roach clasp, which approaches the undercut from a gingival direction, passing over the undercut, crossing the gingival sulcus, and then engaging the undercut. Here in this case, it engages two undercuts, one on the mesial and one on the distal surface of the labial surface of the tooth. So, what is the difference between a supra-bulge and infra-bulge class design? Supra-bulge class design, as I mentioned, approach undercut occlusally. Infra-bulge approaches the undercut from a apical direction. Supra-bulge require less force for the removal, whereas infra-bulge class have excellent retention and require more force. In supra-bulge class, the retentive arm is longer. In an infra-bulge class, the retentive clasp is shorter, or there is no retentive arm. We just have a mesial rest. Now, second, coming to the various types of supra-bulge class. There are many types of supra-bulge class design that have been given over the years by various authors. They are also available in all of your textbooks, such as Stewart's and McCracken's and textbook of Prosthodontics by Dr. Padmanabhan and so on. So, based on this, the first and most simple form is known as a C clasp or a cast circumferential clasp or a simple circlet clasp. Second is a reverse circlet clasp. Then we have multiple circlet clasp. We have embrasure clasp. We have ring clasp. We have onlay clasp, and we have rod wire circumferential clasp or a combination clasp. So next, this is a simple cast circumferential clasp. It has a shoulder, a body, a rest, a reciprocal arm, and a retentive arm. This is the most basic clasp assembly design, which is used in most of the class 3 and class 4 are facing towards each other. Whereas in an embracing class, the retentive class tips are facing away from each other. One is pointed mesially, another is pointed distally. And these are the reciprocal arm which are placed at the height of contour or above the height of contour of the abutment teeth on the opposite side. And the clasp engage the undercut. So this is the supra-bulge clasp again, and we have joint rests. But these type of clasps require more interocclusal space. It is difficult to seat the cast framework at the time of the framework fit-in appointment, and we have to provide sufficient clearance from the opposing teeth. Next is a ring clasp. A ring clasp is just like the name suggests, it is like a continuous ring that is runs from the minor connector on one side and then continues all the way around the tooth and literally encircles the complete tooth. That is, it offers around 340 to 350-degree encirclement, and there is no separate reciprocal arm. The shoulder and the body of the clasp is acts as a reciprocal arm. The tip acts as the retentive terminal, and this portion, second rest, which is placed opposite to the first rest, acts as a also as a what do you call as a support element, that is as a rest stop preventing the sinking of the RPD. And usually this clasp is typically used on severely tilted mandibular third molars or the mandibular second molars when the first or second molar is missing for a long time and the last or the terminal molar has tilted and the undercut lies on the lingual side of the abutment tooth. So that is in only the cases where you would use a ring clasp. So you always have to ensure you have two rests, one attached to the shoulder and body of the clasp assembly and second which is attached to the opposite side of the tooth surface. If you just have one class, this is very flexible and will put torquing forces on the tooth and may cause distortion of the CPD. Next is the hairpin clasp. A hairpin clasp is a simple circuit clasp, but the undercut is lying on the same side of the minor connector or the body of the clasp. So the simple circuit clasp then takes a U-turn and then comes back to the engage the mesial undercut. Usually when we have we use this in Kennedy's class 3 situations when we have a tilted abutment just distal to the edentulous space. So this is how you see we have a simple circular class that goes back to engage the mesial undercut. So this is why it is known as a hairpin, because like you have hairpin bends on roads or tracks on hills, that's why it's called as a hairpin. Next is a half and half clasp. A half and half clasp is a disjointed clasp. In all the other clasp assemblies, the retentive arm and the reciprocal arm are all attached to the minor connector, one common minor connector, whereas here we have two minor connectors. One is attached to the reciprocal arm, the another is attached to the retentive arm. So one is completely disjointed from the clasp assembly on the placed on the parietal side or the lingual side, another is placed on the buccal side from a separate minor connector. So this is why it is known as a half and half clasp. Half of the clasp is on the lingual side, another half of the clasp assembly is on the buccal side. Okay, so this provides good bracing action, and the lingual arm utilizes the undercut adjacent to the edentulous space for the retention. Now coming to the back action clasp. Back action clasp is like a ring clasp, but here the undercut is on the buccal surface and it is not used in a tilted abutment or a tilted molar like in case of a ring clasp. So again, it has more flexibility because it has a long class that originates from one minor character and encircles the tooth all around to the opposite side. So it becomes more flexible, produces more talking forces on abutment teeth, and is not very retentive. Next, coming to the combination class. Combination class is a combination of a wrought wire retentive clasp arm and a cast rest and the reciprocal arm. So here, when the wax pattern is fabricated for the CPD framework, instead of a wax pattern on the retentive arm or the retentive clasp, we place a wrought wire clasp which is attached to the wax pattern before the casting, and thus it becomes incorporated in the casting, or it can be welded later on also. So this is done when the undercut is large, and putting a cast clasp arm in a deep undercut will make the CPD framework very difficult to remove. In deep undercuts, when we have a wrought wire clasp, they are more flexible and therefore they can be easily placed in deep undercuts and they can be easily removed without difficulty by the patient themselves. This can also be used when a patient has fractured his retentive clasp or retentive clasp terminal after insertion of the RPD, say after a year and two, and everything else is good in the cast partial denture, and you just want a retentive element on that abutment tooth which has been broken. So in that case, you can weld a wrought wire clasp. So this is the combination of a wrought wire and the cast chrome cobalt alloy. That's why it's called as a combination. Just of features. So what is an indirect retainer? So we now know that direct retainers are nothing but the clasp assemblies and the precision attachments which are placed on the abutment teeth for the retention of the cast partial framework, and they are attached by minor connector to the major connector, okay, or by minor connector to the denture base or the minor connector which attaches to the denture base. Indirect retainers, however, are basically in crude form, they are just rests which are placed anterior to the fulcrum line. So if these are the direct retainers and the fulcrum line passes through the direct retainers on the right side to the left side, any rest which is placed anterior to the fulcrum line on the teeth which are anterior to the fulcrum line is known as an indirect retainer. It may be a simple rest such as a cingulum rest, an incisal rest, or a occlusal rest. If it is placed anterior to the fulcrum line at right angle to the fulcrum line, it is known as an indirect retainer, such as you know here. This mesial rests on this tooth acts as an indirect retainer. Over here, this cingulum rests on the canine and on the lateral incisor will act as an indirect retainer. So now coming to the denture base. As you all know, denture base framework is also known as a minor connector. They may be lattice type. We discussed this in the last lecture on major connectors, minor connectors, and depending on the design, it may be lattice, saddle, or the bead types. Okay, so next, coming to the artificial teeth in our removable partial dentures. The artificial teeth used in removable partial dentures are the same teeth which you used in the rehabilitation of patients using complete removable dentures or complete dentures. So the artificial teeth in RPD and complete dentures are also known as the tooth component or the occlusal surface or occluding surfaces of the denture. So this is the portion of the denture or dentition which makes contact with the opposing dentition, and there are many types of manufacturers and many types of materials that are being used for the fabrication of denture teeth. They are available in different molds, they are available in different shades and in different sizes. So one of the type of acrylic teeth or denture teeth is IPN, that is interpenetrating polymer network teeth, and these are manufactured by Dentsply, and they come in the by the brand name of Biotone IPN. They have greater color stability, they have greater resistance to solubility, and they have higher hardness than the conventional polymethyl methacrylate or PMMA acrylic teeth. So because they have two polymer networks entangled within each other, so they have greater resistance to fracture and greater hardness. And this is the typical IPN network. One network is encompassed within the another network. Okay, so these are manufactured by Dentsply, and they are known as IPN. And next is the porcelain teeth. The use of porcelain teeth has diminished or dwindled over the past 2 decades a lot, because porcelain teeth are very difficult to trim in cases where we have very less occlusogingival interarch space to place the denture teeth because of eruption of the opposing teeth or any other reason. And also because bonding of there is no chemical bond between the denture base and the porcelain teeth. We need metal tags or metal pins to retain the porcelain teeth mechanically in the denture base, so dislodgement of the porcelain teeth is very common, and therefore porcelain teeth use has reduced a lot. And now we also have CAD CAM milled dentures, that is 3D printed dentures, in which we can select the tooth mold digitally, and these teeth mold are then milled, uh, custom milled, and then they are attached with a composite resin to the denture base, or they can also be ordered from the manufacturer. So these are 3D printed or milled, or what do you call, teeth which are ground from a blank of a polymethyl methacrylate blank, and these teeth are then milled using a computer designing and computer aided manufacturing machine, and then these are then attached to the denture base with a flowable resin or the composite resin. Okay, so that brings us to the end of this lecture of direct and indirect retainers.